Welcome to this .NET MAUI DataGrid tutorial. In this video, I will show you how to create a student gradesheet application using the Syncfusion .NET MAUI DataGrid. I will also demonstrate how to implement sorting, grouping, and filtering features within the gradesheet. I open an existing MAUI application. Here, I have already configured the .NET MAUI DataGrid control and specified the source path to display the student gradesheet. To learn how to add the .NET MAUI DataGrid control to your MAUI application, watch the video linked in the YouTube card above or the description below. Now, I run the application. As you can see, the student gradesheet is displayed. Now, I will show you how to implement sorting functionality in the student gradesheet application. First, I move to the View Model class. Here, I declare properties to manage the state of the sorting pop-up, the sort direction, the selected column, the sort description collection, and the list of columns available for sorting. I then create commands to apply sorting and clear existing sorting. These commands are initialized in the initialize commands method. Then, I call the initialize commands method in the constructor. In the execute sort columns method, set is open for sort columns to true to open the sorting pop-up. Within the execute clear sorts method, I check if the sort column descriptions collection is null and exit early. Otherwise, I clear the collection, reset the selected sort column to null, and use the application's dispatcher to safely update the UI thread. Within the dispatch block, I set is open for sort columns to false, which closes the sorting pop-up. I also create the initialize sort group column descriptions method and call it in the constructor. This method initializes the sort column descriptions property by creating a new instance of sort column description collection, setting up the initial state for sorting. Next, I create the method populate column names, which prepares the column names for the UI to sort the data, and call it in the constructor. I get the type object for the grade class and retrieve all its properties. Then, initialize the grid columns list and grid columns for sort list. I iterate through each item in the columns collection. For each item, create a new grid column and add it to the grid columns list. I copy all the columns from grid columns into grid columns for sort, so they can be used for sorting. After that, I remove the first column from the grid columns list to exclude the student ID column, and set the default selected sort column to the first item in the grid columns for sort list. Now, I move to the main page XAML file to design the UI for sorting columns in the data grid. I install the required Syncfusion controls and import all the necessary namespaces, including Syncfusion MAUI pop-up, button, list view, inputs, and core. Next, I integrated a sort chip that opens a pop-up for configuring sorting options. It allows you to select a column from a combo box populated with grid columns and toggle the sort order using a switch. The interface includes labels for ascending and descending to indicate the sort direction clearly. I set the row in which the data grid is placed and bind the sort column descriptions property to the data grid, enabling dynamic control over the sorting behavior. Within the content page, I set styles to the pop-up and chip controls, removing the pop-up header and setting the chip border thickness to 0 for a cleaner appearance. As you can see, the sort chip is displayed. When clicked, it reveals the combo box and switch, allowing you to sort the student gradesheet. Next, I move to the View Model class to implement functionality for grouping the student gradesheet based on a selected category. I add properties such as isOpen for group columns to control the visibility of the group column selection UI, selected group column to store the currently selected column for grouping, group column descriptions to hold the configuration for how data is grouped, grid columns for group, which contains the list of columns available for grouping, the group columns command to open the group column selection UI. and the clear group command to clear all applied groupings and close the UI. Then, I create the method, execute group columns, which sets is open for group columns to true to display the grouping UI. I call this method in the initialize commands method. I also create the execute clear groups method, which clears all groupings and closes the UI. It uses the dispatcher to ensure UI updates occur on the main thread. Then, I call this method in the initialize commands method. Next, I implement the execute add grouping method, which clears previous groupings and adds a new one based on the selected column. In initialize sought group column descriptions, I initialize the collections used for grouping. In the populate column names method, I initialize the list of groupable columns. Copy all the grid columns into it, remove the first column, and set the first available group column as the default selection. Finally, I move to the main page XAML file to design the UI for grouping columns in the data grid. Similar to sorting, grouping functionality has been added to the UI and is bound to the group column descriptions property of the data grid. Now, the group chip is visible in the interface. Clicking the drop-down icon allows you to choose a column name, and the data grid will group the rows based on the selected column. Next, to retrieve records from the student grade sheet based on a condition, I begin by defining properties in the grade sheet view model class. This includes isOpenForFilter columns, which controls the visibility of the filter pop-up. The filter text property stores the actual text entered by the user for filtering, and a delegate named filter changed acts as an event that gets triggered whenever the filter text changes, allowing other parts of the application to respond. I also declare the selected column property to hold the currently selected column for filtering, and the selected condition to store the chosen filter condition, such as contains, equals, or does not equal. Additionally, create a list of columns available for filtering and a list of search conditions to populate the condition drop-down. I declare two commands, filter columns, which opens the filter pop-up, and clear filter, which resets all the filter settings. I initialize these commands in the initialize commands method. In the execute filter columns method, I set is open for filter columns to true to display the filter pop-up. In the execute clear filter method, I reset all filter-related properties and close the pop-up. To define the available filter conditions, I implement the populate search criteria method and call it in the constructor. In the populate column names method, I create lists to hold columns for filtering. I add a default option, all columns, to the filter dropdown and copy all columns into the filter list to make them available for all operations. Then, I remove the student ID column from the filter list and set the selected column property to the first available column in the grid columns for filter list. To enable dynamic filtering based on user input, I create a class named filtering behavior that inherits from the behavior of the SF DataGrid class. In this class, I declare two fields, one to hold a reference to the data grid, and another to access the view model that contains the filtering logic. In the onAttached method, first, I call the base method to ensure any default behavior defined in the behavior class is executed. I assign the SF DataGrid instance to the DataGrid variable, so the behavior can interact with the grid directly. After that, I subscribe to the loaded event. In this method, when the grid is loaded, I retrieve the view model from its binding context and subscribe to the filter text changed event, allowing the behavior to respond whenever the filter text changes. In the onFilter changed method, I check that the view property of the data grid is not null and assign the filter records method to the filter delegate, which defines the logic for determining which records match the filter criteria. Then I call the refresh filter method to apply the updated filtering logic. Now, I move to the view model class to implement the filter records method. In this method, I check that no column or condition is selected. In that case, There's no filter applied, so I return true to include all records. Next, I define a variable. Then I check whether the filter text is numeric, which helps to decide whether to apply a numeric or string-based filter. I try to cast the object to a grade class. If it fails, the item is ignored. Next, I check if the item and selected column are not null. Then check if numeric filtering is enabled. The selected column is all columns, and the selected condition is contains. It executes the numeric filtering logic and returns whether the filter condition is satisfied. In the makeNumericFilter method, I get the property info from the grade object. If the property does not exist, return false. Otherwise, retrieve the actual value of that property. I define a variable and check if the value is numeric. Based on the selected condition, compare it with the filter text. If the condition is equals, the method returns true if the values match. If the condition is does not equal, it returns true if the values differ. If the value is not numeric, or doesn't meet the condition, the method returns false. Now, I return to the filter records method. In the else if statement, I check if all the columns are selected, and the filter text appears in any properties of the grade object. If a match is found, it returns true. Otherwise, it returns false. If a specific column is selected, and the filter is not numeric, I apply a string-based filter logic using the makeStringFilter method and return the appropriate result. In this method, I get the property value from the grade object. I convert both the property value and the filter text to lowercase for a case-insensitive comparison. I retrieve all methods available on the string type and invoke the contains method to check if it includes the filter text. If the condition is labeled as equals, it returns the value of result, which indicates whether the two values are equal. If the condition is does not equal and the values are equal, it returns false. If the condition is does not equal and the values are not equal, it returns true. If none of the conditions match or no valid string methods are found, the method returns false. Finally, I return to the filtering behavior class to implement the onDetachingFrom method. I start by calling the base method to ensure any default detachment logic is executed. Then, unsubscribe the datasets loaded event handler from the loaded event to prevent it from being called after the behavior is removed. I also unsubscribe the onFilterChanged method from the filterTextChanged event to avoid unexpected behavior. I set the grade sheet view model to null, making sure the object can be cleaned up if it's no longer needed. Now, I move to the main page XAML to design the UI for filtering columns. Within the behaviors element of the data grid, I configure a custom filtering behavior class to manage the filtering logic based on user input. Inside the grid layout, I implemented a filter chip that opens a pop-up to choose a condition and a column from drop-down lists, type in filter text, and clear the filter whenever needed. When the application loads, I tap on the filter chip and search for the column that contains art. The data grid is filtered accordingly and displays only the student records in which the course name includes art. Next, I change the filter condition to does not equal. Select the column ID and enter the value in the search box. As a result, the grid updates to show all records except those with an ID of 19. Let me wrap up this video. You have learned to create a student grade sheet application using the Syncfusion .NET MAUI DataGrid. You also learned how to implement sorting, grouping, and filtering features within the grade sheet. If you want to see this example's working code, download it from the GitHub link in the description below. I have also included a link where you can check if you qualify for our community license, which gives you a free license key for all our .NET MAUI controls. If you found this video helpful, click the like button and subscribe to our channel to watch more videos like this. Thanks for watching.